So of course I'm going to start by saying thank you everyone for joining. My name is Cody Armstrong, and today we're discussing working with library parts in Onshape. So this is a bit of a different subject. We're not going to spend as much time building models or CAD modeling in particular, but more going over the structure of models and how we deal with things that are shared across multiple projects. As I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions section in the GoToWebinar control panel. Feel free to ask any question that you'd like, and I'll do my best to stop and answer the questions as we go through today's webinar. Again, thank you everyone for attending. I know today's webinar was a bit out of sorts. Hopefully the rest of it will go smoothly. So again, the topic is really stemming from a frequently asked question that comes up quite often, and that is, how do I handle library parts in Onshape? And library parts kind of has a generic term. I'm going to go over what I kind of envision when someone says library parts, and then that may differ from what you do, right, in your organization. So we're going to start briefly with just what do we call a library part, and this is just kind of a generic term. There's no formal definition for library in Onshape. It's just a term that I use for things that are shared across multiple projects, right, or across multiple documents. Then we're going to go over the specifics of how we handle them in Onshape, and I'm going to go over an example that I have for you of just how you might structure something. And examples are difficult because it's hard to find an example that relates to every industry and every product. But I do have a good example of something that's relatively good sized and has a good combination of things that are shared and things that are unique to the project. Now, of course, as always, please ask any questions that you'd like. There's that questions section in the GoToWebinar control panel. Ask any question you'd like, and I'll stop from time to time and answer those questions. All right, so let's get into it. What are library parts? It's important to stress this term is, a very much generic one, right? And as I mentioned earlier, a lot of companies have different definitions for this, right? Shared parts, I've heard the term, or project, things that are outside of the project, non-project specific things. So think of any part or assembly that is used in multiple projects. In multiple places within your company, you insert this part or this subassembly, right? So it's not specific to any individual project, right? It's something that's used in multiple places. Now, there's a lot of things that fall into that category, and generally they're kind of two big hoppers, so to speak, for categories: imported geometry or created geometry. And sometimes there's even the, of course, occasion where it's both, right? So maybe I've imported a pump, but we build a housing for the pump and a frame, and that's our library subassembly, right? Or in that case, it would be a combination of an imported and created geometry. But again, some of these things and how you define them makes a big difference downstream when you start building your projects out. So in short, what is a library part? It's just any part or assembly that's used in multiple projects, multiple places, right? That could be something as simple as a nut or a bolt. Maybe you're importing a nut or a bolt that isn't in our standard content library, and you need to use it in a number of different projects. That could be an example of a library part. But it also could mean library subassemblies. Maybe you have a product line that has shared subassemblies, right? The subassemblies in multiple different projects. That's also, a library part. So, again, it's important not to get too hung up on the definition, but just think of it as any part or assembly that's used in multiple places. So, I'm going to go over this in another way in just a moment, so bear with me. But the question comes up, how do I handle library parts? And it's not just a matter of, how do I insert them or what's the best way to make them, but it's also, where do I store them? Where should they go in the same document as the project? Should they go in a different document as the project? How should I version control them? Should they go into their own documents or just one big library parts document? That's a question that comes up quite often. So there's a few things to consider. At the basic level in Onshape, the document is that project level container. Now, in Enterprise, we have the concept of a project with a folder, and you can have subfolders within that and documents. But for the sake of simplicity, just keeping this simple, in this example, we have just the project. right? And that project is that single document. And within the document, you have part studios, you have assemblies, you have imported data, you have essentially anything that's unique to that project, right? The key, again, is unique to that project. There are going to be things that are library components or reused data, and those will be in a different document. So if there's one tip that I would take away, the one tip that I would give you throughout this entire webinar is, just make sure to store your library parts or subassemblies in separate documents from the project, right? So anything that's used in multiple places should be in its own document or in a document with similar things. Right. Now, I'm going to go over an example of these in more detail in just a moment, but that's the important lesson to stress throughout this webinar is, again, those things that are shared, that are reused in multiple places, they should not be in just some random project. They should be either in their own document or with, in a document with other similar library parts or subassemblies. So that's the important thing to stress. Separate documents for your library parts or any kind of reused data. Now, that also means that you need to know how to use linked documents, right? So if you're not familiar with it, we're not going to spend a ton of time on linked documents here or the logistics of using them, creating versions and inserting them. Definitely check out past webinars and videos we've done on linked documents. But essentially, everything that's a library component will be inserted as linked, right? And meaning you'll need to have a version established. You'll need to insert that version. So I'm going to go over the details of that as well in just a bit. So the example, as I mentioned before, it's difficult to pull an example that applies to everyone, but I do think this is a good one because it is an example of something I've heard of quite often, and that is, we have several subassemblies that are used in many different projects, right? And our unique project, it really only has one or two subassemblies, and everything else really comes from the standard library of subassemblies that we work with. Right? And a good example of that would be something like a conveyor system. Right? This is a bonding and screwing machine where you have, I have these individual pieces of machinery that we use in multiple different projects. But what we do with each project is build a unique conveyor, right, that joins all of these pieces of machinery together. So this is an excellent example of a subassembly being a library subassembly. Right? The bonding machine or the screwing machine is a subassembly we use in multiple different places. Right, the conveyor is the thing that changes and the thing that's unique to that project. Right. So the other thing that this introduces is kind of one more level of granularity when we talk about library. So when we talk about library subassemblies, you can think of my company designs big bonding and screwing machines. And we work with 3 different subassemblies or bonding and screwing machine types, and we drop those in as library assemblies. Those bonding and screwing machines may change over time. We control that design, right? So they may change over time, and those changes, I'd want to insert into the latest designs. And then there's also this category of, largely imported data, things that don't change. Right. So even within your library parts, I have library assemblies within our company that do change over time, and then we have these kind of static library of parts that don't change. Those tend to be the imported simple nuts and bolts and casters and all the kind of hardware that's often standard defined and rarely changes. And if it does, then it's a whole different part number and it's more involved. So those are, at least within the library of parts and subassemblies, 2 different categories to consider. And this kind of takes into account, this example kind of takes that into account as well. So one question that I think is important to ask yourself is how often is this library part or subassembly going to change, right? And that will often answer the question of whether it should go into its own document or into a document that's already existing. A good example would be, let's say that I have different casters. I could put them all into a document called casters, right? And let's say, for instance, that we start using a new style of caster. I could just add that to the document called casters, version it, and then I can insert that new caster into anywhere that I'd like. That'd be a good example of something that doesn't change often. Right? So Just two things to consider even within the concept of libraries is you may have shared things that change often and then things that don't. All right, so what I'd like to do is get into an example. So bear with me for just a moment here. Now what I have is this bonding and screwing machine. As I mentioned before, this design in this example consists of 4 or 5 assemblies that are in essence library, right? They are assemblies we use in a lot of different places, right? So what you'll see when this loads is that they are linked documents. If we look closely, right, we have several assemblies here that are linked. You can see the linked documents here, right? So the lifter assembly, right? Both lifter assemblies on either end are linked documents. The bonding machine is a linked document. The screwing machine, right, a linked document. Really the only things unique to this project, the only things that are really controlled in this document are the conveyor assembly, right, and in this case, the assembly of product being moved across the conveyor. Right? Those are the things that are unique to this project. The bonding and screwing machines, the lifter assemblies, those are things that we use in multiple different projects. Right? That's the important thing to stress. Right? So, what does it take to make this work? The important thing I would stress with this is these are linked documents. So if you're not familiar with the linked document process, that's the prerequisite. You need to know how to insert linked documents, and you know how to version. Right? So if I switch tabs here, let's just jump into the screw machine. These are separate documents, right? So in this case, I've designed the screw machine in a totally different document, by itself. That's version controlled separately from, anywhere where I may insert it, right? So here you can see the screw machine, right? So again, these are all independent documents. Let's go ahead and refresh these as well. One tip that I would have for you is when you're considering this kind of structure, getting back and forth between the documents is a very important thing. So anytime you've inserted a linked document, you have a right-click menu option that just makes getting around very easy. If I needed to open up the bond machine assembly or the lifter assemblies, I would just right-click and choose the option to open linked document. Right? But this is a great example, again, for that reason. It kind of illustrates, here are the different subassemblies, right? In this case, these are shared subassemblies. These are subassemblies that are in different projects, right? Now, the key to this, the most important thing to stress when doing this kind of design is that you must have a version of that assembly in order to insert it anywhere else, right? So one of the first tips that I would stress is, when you're building your library assemblies, once you've reached a point where you're ready to insert that library assembly into another document, create a version first, right? And then you can take that and drop that into, your linked document. But the very important prerequisite, again, if you haven't used linked documents, make sure to create those versions and then insert those versions into the other documents, right? Now, to make this even potentially more complex, real products have lots of layers, right? And so when you take a look at the top level assembly, we had a bonding and screwing machine, we had these lifter assemblies on the ends. Those were library assemblies that we use in multiple places. Even within the library assemblies, you may have library parts, right? So a good example of that, this is the bonding machine assembly, but it has caster wheels, right? These caster wheels are a separate subassembly that's also linked, right? So these caster wheels are in their own linked document, right? That are referenced in this subassembly. So the example I would stress here is, this is a great example of where, these things don't change often, right? The caster wheels or the nuts and bolts, the simple hardware, the stuff that doesn't change often should really be in its own document, right? I would not want to put, the caster wheels into the same document as the bond machine assembly, Because the caster wheels I would use not only in this subassembly, but I would use in multiple different subassemblies. And they don't change often, so they should really be in a separate document. Right? Now, the other thing to consider here is version control. Right? So when you deal with linked documents, you have to deal with the idea of updating versions. Right? And that's why it's important to delineate between things that don't update often and things that do, because they should really be in separate documents. Right? The caster wheels, putting them into this document doesn't make a lot of sense, but I can put them into, their own document, and now they have their own version control. Right? And so when I version this subassembly, it's not triggering a version. I'm not versioning the caster wheels as well, right? Because I've put them all together. So, important thing to consider again, even within your library subassemblies, like this bonding machine that's used in multiple places, you're going to have library parts, the caster wheels, the housings, the kind of generic stuff that you may download, the things that don't change often. And I definitely recommend those being in their own documents, right? So if we right click here, you can see I can open linked document. That will take me to a specific document that is nothing but caster wheels, right? So maybe I created a document of nothing but caster wheels. So again, important to stress, there are multiple levels to this, and that's just, real product design. Even within your library subassemblies, you're going to have library parts, and those are all things that you need to consider. But again, the big thing to ask yourself, the question you need to ask yourself is, how often does this change? Caster wheels don't change often. They should probably be in their own document, or perhaps in a document of library parts, right? Where in a folder called caster wheels. I've seen other companies, they would put everything in a single, all the the static parts, I should say, the parts that don't change often, put them in a single document. It just depends on the sheer number of them, right? So that is the simple example that I wanted to lay out for you. Question: nothing Bluetooth seems to work with this webinar software. Works just fine when the app is closed. Forgive me, I'm not sure I followed there. There is, if you're referring to audio, there is a dial-in number as a last resort. So forgive me, I'm not sure I follow. All right, so if we jump back to, let's go back to the bonding and screwing machine top level. As I mentioned before, lifter assemblies, right? The bonding and screwing machines themselves, they're library subassemblies, right? The only real assemblies that I'm working with are the conveyor subassembly that's unique to this project, and the actual subassembly that's the product, relatively simple subassembly, right? All right, so in an example like this, what does it look like? What does the structure look like? And so if we take the example I showed you before and just kind of make that a bit more detailed, right? We have the top level assembly. That is the bonding and screwing machine assembly, complete with conveyor. It's a fully built assembly. That top level assembly consists of references to multiple subassemblies. Those subassemblies exist in different documents, right? With the exception of the actual conveyor assembly, right? The thing that joins all the library assemblies, that is built in the top level document here. But everything else is a reference to a different document, something that's used in multiple places, right? So the big thing I'm going to stress is both at the top level and within subassembly documents, you can insert that reused data, the custom library components, in multiple places. And there will be scenarios like the example I gave you a moment ago, where it's nested, where you have a library subassembly with library parts within it, and those are in different documents just because of the nature of how you want your data structured. Right. Question: can we get a link to the linked document webinar? Yes. Bear with me. I will make sure to give you that before we wrap things up here. All right. So again, just to stress, it's important to take those, the library parts, the library subassemblies, and put them into their own documents. And that's very important to the structure. And that answers the question of how should I store my library parts? How should I store my library subassemblies? Now, what I'd like to do is get into just a few tips that I have for how to actually accomplish this, right? So we talked about, what it should look like. What do we recommend in terms of where to store things, in terms of in a different document or in the same document? But what happens if, I need to accomplish this in something that's already been created? That's one of the more common questions I get is, okay, that's great. You've shown me how to do this, but I've already got everything in a single document. How do I move stuff around, or how do I get things out of one document and into another? And the short answer is move to document. Again, the question, what happens if you built something in the wrong place, right? Or what happens if you've imported something into the wrong document? How do you then take that and move it to a different document? And I still see a lot of users to this day will delete and reinsert when that's really not necessary. You can easily just move. So how do we do this? It's really just a right-click menu option. All right, so you right-click a tab and you'll see the option Move to Document. Now, when you're doing a move to document, you have two options. You can either create a new document or you can move to an existing document. You'll see Other Documents at the top of the Move dialog. So you have those two options. It really depends on what you're doing and what you hope to accomplish. The last thing I would stress, this is a commonly asked question when I show Move to Document, is it will automatically move any reference, right? And it will replace the reference in the original assembly to the linked document. So you don't have to worry about if you move something all of a sudden anywhere where it was inserted, or originally inserted, those references falling apart, right? Or anywhere was originally inserted, those assemblies breaking. Onshape will automatically re-reference to the linked document. And it will also grab all the references to whatever tab that you're moving. So if I right-click an assembly tab and I say Move to Document, it's going to grab any Part Studio that's referenced in that assembly. Right, if I right-click a drawing, for instance, and say Move, it's going to grab the drawing reference and then any reference in there. So if I'm moving in a top-level assembly drawing, it will grab the top-level assembly and all the Part Studios and move them all as one command. So I do want to briefly just show you this. It's a relatively simple thing to show, but again, it's all accessible via the right-click menu. So in this example, let's say, for instance, that this bike shock is actually used in multiple different bike frames that we design. And I originally put it in this document, but now I know I need to move this to some other place, right? So I can right-click on it, and you'll see the Move to Document option, right? So you choose Move to Document, and there is the two options that we discussed. Either create a new document or move to an existing document. You could choose Other Documents and just browse to your list of documents, right? But that's really it. If you click, it will show you here are the tabs that are being moved. Remember, as I mentioned before, it's going to grab anything that's referenced. So if you move an assembly, it's going to grab any Part Studios that are referenced in that assembly. If you move a drawing, it's going to grab any reference in that drawing and move it with it. So it all goes in one shot, so to speak, right? But that's really it. And it will, let's go ahead and give this a name, right? Hit Move, and that will create a new document and, move those tabs into that document. This is how I would address the, scenarios where it was imported into the wrong document, or it was originally created in the wrong document, and you later realize it. That's where Move to Document is really valuable. Again, we really want to stress, putting those library subassemblies or parts into their own document. The bike shock is another good example of that. That is something that we may use in multiple different bike subassemblies. And so it really shouldn't just be in any kind of random document. It should just be in its own document where I can grab it from multiple places, right? So that's Move to Document. The other thing I would stress is anywhere where that bike shock was inserted will automatically be re-referenced wherever it was moved. So you don't have to worry about breaking references when you do a move to. That's a commonly asked question, right? It will automatically update with any reference. All right, so that is Move to Document, a very important part of actually accomplishing, the split out workflow of being able to delineate between library parts and project specific models. Okay, so another tip that I have for working with library parts, and that is explicit make connectors. So the nature of library parts is that they're inserted often, just given the name and the how they're used. Library parts are typically inserted in multiple places, and so there's an even bigger benefit to adding explicit make connectors to library parts, right? So the spring example, for instance, let's say that I'm constantly adding a custom mate connector whenever I insert, or let's say that I'm struggling to mate this part into place every time that I insert, and I insert it in multiple places. There's a big benefit to creating an explicit mate connector. The biggest thing that I would stress is this is really just about making the inserting and mating of the assembly faster, right? So if you've ever, if you have the spring or the bolt or whatever it is, and you find yourself constantly having to rotate and then offset and do these tweaks to the individual mates, you can easily just add an explicit mate connector to do that, right? All right, so if I want to move just the assembly but not the parts, especially if they're library parts, is that possible? No, it's going to grab everything referenced. I think that's an error. You'd have to create a new document, create a new assembly, and then insert linked documents to all those parts. Essentially rebuild the assembly as referenced. Today, when you go to move to document, it's going to grab by default all the references, right? Is there a video to follow along? No, I'm going to show my screen in just a moment, so bear with me, but there's no video to as a second form of instruction to this. If you're interested in videos, I definitely recommend check out the Onshape Learning Center. We do have videos on explicit mate connectors and a number of these things. All right, so I'm going to go over this in just a moment, but explicit mate connectors combined with snap mode make for a very fast way of inserting and mating the assembly. Right? It's a substantial difference in terms of speed to assemble your assemblies if you're using explicit mate connectors and snap mode. It's definitely a higher level technique. It's what I would consider kind of a power user technique, but it is very, very quick. So just bear with me for a moment here. I want to go over an example. All right, so give me just 1 second here. All right, so what I've done is open up the bike shock. Right? This is the bike shock assembly that we moved to its own document. Right? So again, we've just taken the assembly tab and its part studio and brought it into its own document. This was a tab or a few tabs in the document we were looking at just a moment ago. And what I'd like to do is go over how we might explicitly define a mate connector in this example. Right, so let's say, for instance, that this is the spring that I use in my bike shock, and I use it in a number of different bike shocks, and I want to simplify the insertion process of the spring. Right, maybe I struggle to mate it, or maybe I find myself constantly adding these combinations of mates or offsets or things like that, just making it more work. What I could easily do is instead define an explicit mate connector. Right, so here is the mate connector command. I definitely recommend doing this at the part studio level if it's a part that you're inserting into other places. Right? So in this example, the spring is the part that I'm inserting into other places. I want to make sure that I have this mate connector wherever I insert that spring. Right? But I could also create a mate connector at the subassembly level. Right? I could easily define a mate connector at the center of the mount point on the shock here and have that simplify the insertion of the subassembly. Right? So there's no reason to limit it to just parts. But again, the big thing with stress, you create a mate connector. You define where that mate connector goes. Let's just say the end here. One big tip that I have for you is when you're doing mate connectors, especially in multi-part studios, you want to make sure the owner part is correctly defined, right? So in this example, I have a construction cylinder that's used to build the spring, but the spring is really what I'm inserting into other assemblies. So I want to make sure the owner part is defined as the spring, not the construction cylinder. But that's really it. Now, anytime I go to insert this, spring, let's go to insert the bumper spring here, it will come with that mate connector. Whether they insert that into this shock or into a whole different document, again, keep in mind, this is how we get the explicit mate connectors, into your parts. And this mate connector will come, with the spring anywhere that you insert it. Right? Now, keep in mind, in order for this mate connector to be visible, if I inserted this into other documents, I would need to create a version first. So just to stress this again, before you can insert, versions, linked documents, like we discussed earlier, you must create versions. Right? That's an important first step. Right? But that's creating explicit mate connectors. And for library parts, things that you insert often, there's a real benefit in time in taking the effort and explicitly defining this is my attachment point. It will simplify all the downstream mates that you're going to do. Right? So it just makes it easier for anyone that's building this to understand this is its attachment point. Right? And if you're doing a lot of inserting and mating of the same part, that could make a real difference, right? Especially in library parts, that makes the most sense. All right, so I mentioned this combined with snap mode. Snap mode is a mode that you enable in Onshape that allows you to simply drag one part over another and automatically mate the parts together. Now, if you combine this with the insertion of parts, it really makes it very quick to insert and mate parts into your assembly. This is really powerful with library parts because of the inherent nature of creating explicit mate connectors. I showed you a moment ago, it's very common in library parts to insert mate connectors where they attach. Snap mode will use those explicit mate connectors as potential attachment points on insert. So it makes it a very quick way to insert. You don't even have to leave the insert dialog. You don't have to mate things separately. It literally just drag and drop, and it inserts mates, and you're ready to move on to the next one. This is definitely a higher level skill. This is not something I would start with. But if you're looking for fast ways to assemble library parts, snap mode is definitely a big tip that I have for you. So bear with me for a moment. I want to show you an example. This is an example of a pneumatic cylinder, right? And let's just say that I build, variations of these assemblies all the time, right? Different cylinders, different sizes. And you can see at the very bottom here, I have 3 explicitly defined mate connectors, right? So in this example, in this part studio, I've built these mate connectors to make it easy for me to insert. Right? If I go in and just edit one of these mate connectors, you can see it's referencing the end cap. So the end cap has a mate connector where its attachment point is defined beforehand in the part studio. Now, the advantage to this, the reason that this is powerful, is it allows me to enable snap mode and then automatically place on insert. Right? So important tip, you need to turn snap mode on. Right? It's a mode that's either on or off. Then go to insert. Right? Now that I go to insert, choose a part with an explicitly defined mate connector like the end cap that I was showing you just a moment ago. And what you'll see is it will automatically attempt to attach itself to any geometry that you move your cursor over. So you've defined this is my attachment point, and as part of the insertion process, I can say, okay, it should go here, or it should go here, and maybe I use the A key to flip the primary axis, right, to rotate the primary axis, or I use the Q key to reorient the secondary axis, right? So the big advantage of this is that if I've defined an explicit mate connector, this is an end cap that I use in a lot of different assemblies, I left click to place it. Not only have I inserted the end cap into the assembly, but I've also mated the end cap with a fastened mate, right? So I don't have to come back and mate that as a separate step. Again, definitely something that is very powerful, something that you may not always use, but for library parts, it is a big speed improvement, right? So I think for library parts, this is one of my biggest tips. Use the explicit make connectors. Use the snap mode. It just makes it really easy to to make things into place. Now, it is not specific to insertion, right? So what I mean by that is I can grab and drag and just while in snap mode, snap the two parts together. So snap mode is just a mode that you turn on, and if you're not in the insert dialog, you just left click drag one part over another, or one make connector over another. You can see there I grabbed my explicit make connector, dragged it over another part, and it snapped the two together. I hit the green check, and now I've mated those two together, right? So snap mode, valuable on insertion, like I showed you a moment ago, but also just valuable if you insert a whole bunch of parts and then want to just drag and drop. You can see that one drag and drop, again, mated the part into place. So snap mode, explicit make connectors, all very valuable when working with library parts in general, just because of how frequently they are inserted. All right, so one of the last things that I wanted to discuss is configurations. Question, is the A or Q in the standard quick key library? I believe so. Give me just 1 second here. Keyboard shortcuts. Yes, they are. Right, so right here, flip primary axis and reorient secondary axis, right? So just a tip, this is kind of an aside, but I definitely recommend if you're interested in keyboard shortcuts, especially with some of the snap mode that I was showing you a moment ago, keyboard shortcuts are kind of a must in that scenario. Under the question mark, you'll find keyboard shortcuts, and A and Q are there for flip primary and reorient secondary. All right, so that is, again, explicit make connectors, snap mode. I think those are both valuable things to consider if you do a lot of work with library parts and inserting and mating of library parts. Now, the question that comes up often when we talk about library parts is configurations, and they very much tie, hand in hand. When we insert library parts, we often want to configure them to a certain size and then insert them. And it's just the nature of library parts. They tend to be very configurable. Not always, but often, right? So one of the first questions that comes up is, can you insert configurations of something into something else? And the answer is yes, right? So configured library parts, very common, right? And the coolest thing about this is they can be configured upon insert. So if you've built a library of configuration variables and you want to build a configuration on the fly as you insert, you could do that. Now, one very important thing to stress is, again, using versions. So create your configured parts, right? Version it, and then go to anywhere that you want to insert that and insert that version. So I do have a very simple example of this just to kind of show you. But the big thing that I would stress again is just the use of versions, right? So aside from capturing that version, there's really not anything different in terms of creating the configurations. So bear with me for a moment. So let's say, for instance, that I work a lot with springs. And I find myself working with springs, and I essentially just have 4 or 5 variable inputs, and I need to be able to build any kind of spring on the fly and insert it into any assembly that I want. And they may be project-specific assemblies, they may be library subassemblies. We just work a lot with springs, right? And so this is a great example where I might build a configurable spring and then insert that anywhere that I'd like. Right? So if we look at this, this is an example of a configured part studio. Right? So in this example, spring length, spring diameter, spring turns are all independently defined as configuration variables, which means that I can go in and type in a different configuration variable for turns or diameter, right, or length, and it will build that spring on the fly. Now, if you haven't spent much time in configurations, I definitely recommend checking out past webinars we've done on configurations. Goes over building, these kinds of configuration variables and inputs that you may want to. This is admittedly a very simple example, but I think it drives home the idea of using a linked document. This is a library of spring parts, and I've put them into a separate document that I've configured. And you can even configure imported geometry. Maybe you import hydraulic cylinders. I can easily simplify a hydraulic cylinder and have a, move face accomplish the stroke adjustments that I may have for different cylinder sizes. So there's lots of great techniques for working with imported models and even configuring them, right? But from this point, I can easily go to any other assembly in any other document as long as I've created a version in the spring library, forgive me, right? So V1, V2, you can see I've already got my V1 version here. I could go to any other document, go to Insert, choose Other Documents, right? Let's go to our recently opened, should be in that list, and there is my spring library. I can left click, and here is where I'd configure on the fly, right? So by default, it's going to bring up one of the configurations we used in the past, but I can easily change this to, let's say, okay, I want a 10 with a spring diameter of, let's say, 4 and number of turns 6, right? And I'll hit generate, and it's going to build that configuration. Even though I've never built that configuration in the past, it's going to build that as part of this, right? And then I can easily go in and drop in that spring is definitely too big. So, but I think you get the idea. I've built this spring on the fly and referenced a different document to accomplish it. And again, as long as you're storing your springs or your nuts and bolts, your specialty hardware, whatever it may be, in its own document, you can essentially build in configuration you want, right? Kind of on the fly, as I've done in this example, right? So, again, the big thing to stress is, yes, configurations are supported. The key things to stress about that is make sure that you've built out all the details of your configurations first, then create a version, and then when you're inserting that version, that part or that subassembly, you can build it on the fly. One other thing, caveat to stress, configurations are not yet at the assembly level, right, which would take this to the next level, but as of today, configurations are specific to the Part Studios, right? All right, so that is what I had planned for you. Again, just to stress it, yes, you can insert configurations of Part Studios, and you can do that on the fly. The big thing to stress is build your configurations, version the document, and then you can insert it anywhere that you'd like. Very common from the examples I've seen in library part scenarios to have lots of configurations. All right, so I am going to stick around and answer any outstanding questions. So please feel free to ask any questions that you'd like. There's a question section there in the GoToWebinar control panel. Again, ask any question you like. I'll stick around for a few more minutes and make sure they are all addressed. But that's it, everyone. One last comment. If you're interested in learning more, both on this topic and any other topic in Onshape, the Onshape Learning Center is the best resource for you. So there's self-paced training. You can take training at your own pace, at your own time. Instructor-led training, so an Onshape instructor following you through learning Onshape. And then finally, technical briefings. So technical briefings on specific things, how best to structure your documents, how to use library parts, those types of things. So, all right, so that is what I had planned. Again, I'm going to stick around and answer any outstanding questions, so please feel free to ask any questions that you'd like. But that's it, everyone. Thank you. Again, I apologize for the delays. Hopefully we won't have those issues again. That's it, everyone. Thank you, and have a good day.